Hi, I'm Fred BRECHTEL. Today I'm going to present our miniature optical particle counter, or model 9405, or mOPC. It's a relatively compact device. This dimension is only 6 inches. That measures the size and number concentration of sampled particles passing into the sample inlet, which is right here. The optical particle counter employs a laser inside itself to shine light on sampled particles as they're accelerated through a nozzle, and each of those individual scattered light pulses are measured by one of two detectors. The detectors measure the amount of energy scattered by the individual particles. That's proportional to diameter via calibration. And then each pulse is counted as an individual particle. So given the flow rate going through the device, the sample flow rate, we can calculate a number concentration by counting the individual pulses. We only do single particle counting in the OPC. We do not use any kind of photometric mode or try to measure the number concentration when we have multiple particles in the scattering volume at the same time. So let me see if I can hold this up close enough to depict some of the details here. So one of the things to remember with all of our UAV modules is you can see that we've left the device as small as possible. It's very light, with the idea that you can deploy it in your unique application and fit it into a very small space. Now, having said that, it's important to realize that a lot of these circuit boards have been left exposed. That means that if you have static buildup on yourself and you handle this device and you're not careful about not touching these boards, you can damage them. So be very careful when you handle the device. Do not grab it by the circuit boards. Okay, handle it by the metal bracket down here, and mount it to your setup using the mounting holes that have been provided through the metal bracket here. You can also use these side holes if you need to, but these bottom holes are typically good enough. There are 4 of them provided. So as I mentioned, the sample flow is entering here, and it's passing through a stainless steel laminar flow element. We use this laminar flow element to measure the volumetric flow of the particle-laden air that's going into the unit. You can see here we're using conductive tubing that goes into the device and eventually goes into the nozzle assembly, which is very difficult to see, but it's inside on the side of the optics block. Now this device also has a sheath flow. That's what this second laminar flow element is used to measure. And you can see that we have 2 pumps. There's a carbon vein pump here, and there's another carbon vein pump here. One carbon vein pump is used to provide the sheath flow. That's this guy down here. So it's blowing air out, okay, out of itself. It's passing through a filter. Okay. That filter is the filtered air is coming around. We pass it through a second filter, and then it's coming around through the laminar flow element, passing through the LFE for short, and then this tube is now also going into the OPC, into the nozzle assembly, where the filtered sheath flow surrounds the sample flow to keep the sample flow nicely focused as it passes through the focused laser beam. So we want those intersection volumes to be very well defined and as small as possible. So we're using a filtered sheath flow, and we're using the second pump. Remember, there are 2 pumps. There's the sheath pump and the vacuum pump. The vacuum pump is pulling the total flow out of the back side of the unit on this side. So the software that's running on board here is using the LFE measurements in real time to balance the vacuum suction flow out of the unit and the sheath pressure inlet flow to get the sample flow we want. So for example, we might run a 1.1 liter per minute sheath and a 1.2 liter per minute exit flow from the unit, vacuum flow, and that would give us a 0.1 liter per minute sample flow, which is about what we typically run the unit at. The flows need to be kept relatively low. The pumps are very small, they're not capable of high flow rates, and the unit's really designed for those lower flows. So let me go around the unit and point out a few other details. This board up here is sitting on top of the photomultiplier tube. This is how we detect small particles using 90-degree scattering. This board, on the other hand, this is the forward scatter detector board. So larger particles scatter light preferentially in the forward direction. So we do small particles with 90-degree scattering, and we do the larger particles with forward scattering. So we have two separate detectors in this one unit, and we're looking at both the detectors all the time. Here we have the laser board on this side, so this is controlling the laser power and modulating laser current, etc. And then here we have the main board. And on the main board you can see a variety of hookups. There's an SD card slot, a micro SD card slot here. There's a port here for RS-232 cable connection. There's the USB port, which would be used if you're going to interface with our tablet software, which for the OPC is highly recommended because it's a very complicated instrument. The data acquisition is very complicated. And here is a ribbon cable connection for a display, the same sort of display that's used with all of our UAV modules. Again, I'll remind you that if you're going to attach this display, the black color of the ribbon cable always goes against the brown edge of this connector. All right. Here on the main board, you'll also see several pressure sensors. So we use these differential pressure sensors to measure the pressure drop in the laminar flow element, and that's calibrated at the factory against volumetric flow using NIST-traceable flow meters. Here we have a total pressure sensor that's normally teed into one of these lines, and on this unit, this is a testing unit right now, we don't actually have it teed in. But your unit would have a small T in one of these LFE lines, and a tube would come over to this total pressure sensor here so that we can maintain a measurement of the total pressure inside the instrument so that you could do any kind of STP correction or use it for other kind of diagnostic needs. So again, this is the main board here. This has got a very complicated microcomputer chip on it that's running the firmware, that's doing all the low-level control of the unit. So operating the OPC is actually quite simple. All you need to do is make sure you get it, mounted in your application. Get it fixed down. Sometimes it might be a good idea if you're on a vibrating platform to put some foam or rubber underneath here before you bolt it down, so that you get some vibration isolation. And all you're going to do is you're going to use the supplied power supply that comes with the unit if you're running it in the laboratory, or if you're going to use AC power on your platform. You'll get one of these bricks. It's just an AC input to DC output. Here's the DC output connector supply, and you'll just power it up. So depending on how the defaults are set inside the OPC, you can set the defaults so that the unit automatically turns on and begins acquiring data the minute power is applied. Now, these first versions of the mini OPC require the tablet software hookup because of the complexity of the data acquisition and the processing of the pulses. So we're not going to be storing data locally using the SD card on these initial units. So what you need to do is you'll get your tablet, and you'll go ahead and run the software here. We have the UAV reader software version 4.0 we're shipping right now. And you'll see now that right now these are all grayed out. Let me bring this closer to the screen. Okay, so right now the system isn't recognizing any instruments. These are all grayed out, and that's because nothing is connected yet. Alright, so what you're going to need to do is you'll have plugged in the hub, a little mini USB hub that came with the unit, and you'll plug in the other end of the USB cable from the hub to the OPC, like that. And you heard the unit recognize the instrument, which is good. And now all of a sudden I can see that the system has recognized an OPC. OPC, this is serial number 0 because it's our tester unit for in-house use. And it's actually already telling me it's reading a concentration of about 860 particles per cc. Okay? So now if I want to look at the details of the OPC, I just select the OPC tab. Okay, and if I go to current, now I can begin to see the data being acquired. Okay? So I know this is a crude way of presenting the software, but at least it gives you a rough idea of what data acquisition looks like on the OPC. On the x-axis is size, and on the y-axis is counts. All right, and you'll see here a variety of controls. I can turn it on and off via the software. And if I come back to the All tab, I can turn file saving on right here to save data. That's very important. Okay, I'm just going to turn it back off. If I go back to the OPC page, you can see that the sample flow is set right now to 0.09 liters per minute, and the sheet flow is set to 1.2 liters per minute. All right, and then it tells you what the measured flow rates are. So they're very close to set point. Okay, and pressure hasn't been calibrated, so the value here is incorrect. If I go over here to the OPC Details tab, you can see all kinds of details about the OPC. The calibration coefficients are shown here. Manufacturing info is shown here. I can read the OPC clock by clicking on this button, and then there's some other diagnostic readings here, any errors or the sheath power, the exit pump power, etc. All right. So if you want to run the instrument, then you would simply mount this tablet in a convenient place, click on to save data. You would typically you would connect your sample inlet to this input here. You'd want to run this through a dryer because the particles need to be dry, otherwise the water will affect the sizing in the unit. And you're ready to go. So it's good every once in a while to test the zero to make sure that the unit is leak tight. You can do that by just adding a simple HEPA filter or a little filter like I have here that I've just done here. And now if I go to the OPC tab, I don't see any particles anymore. It's 0. Okay? And then if I take the filter off, all of a sudden there they are again. So that's indicative of a properly operating unit. Okay? So when we're running the unit, you're looking at the flow rates, making sure we're making set point flow. You're making sure that the pumps are operating smoothly and not pulsing. You know, you want to make sure you strain relief cables and whatnot. You can see that I already had attached the power cable over on this side here. All right, there's a cable that comes with a small 2-pin connector that had already been connected into the power board here. Okay, and that distributes 12-volt power to all the other boards. So this comes with your unit. It will probably be in the ship kit. It may not be attached to the board. This is where you need to attach that. We also ship a different version of this with the unit that just has flying leads, so bare wires that you can hook up to your battery. Keep the voltage below 14 volts going into the unit. 12 volts is optimum, but do not over voltage the unit. All right. Well, that's pretty much it. The lower size detection on the unit, the 50% size detection, is in the 160 to 180 nanometer diameter range. And it's designed to measure particles up to 10 microns. Right now we're in a few micron range in terms of detection. The unit is still under final development, but it's operating pretty well. Happy sampling.